Octopuses have 3 hearts. 2 of them pump blood to the gills, while the bigger heart circulates blood to the rest of their body. They also have 9 brains. There's the large central one, but also each of their 8 arms has a mini brain of its own, which is why they can act independently. Since each arm has its own brain, the central brain only needs to send a higher level signal to the arm. Things like, move to that nearby crevice, there might be a crab hiding inside. In the case of humans, the brain would guide and take control of each movement of our legs and arms. And with an octopus, arms act almost independently on their way to the crevice. It also tastes and feels with the suction cups on it. Since their arms are so independent, an octopus doesn't actually know where they are unless it sees them. The human body has an ability called proprioception. Thanks to it, we know where our arm is, even if we hold it, let's say, behind our back. 1816 is known as the year when summer didn't come. In April 1815, there was a massive explosion on Mount Tambora in Indonesia. It sent enormous clouds of volcanic ash up into the atmosphere. The majority of the northern hemisphere got covered with a shroud of dust and dirt and kind of refused to settle. In June of the following year, the cold winter didn't just come to an end. Frost damaged crops, and snow and rain persisted during the whole summer. In Iceland, you'll find some of the most breathtaking sceneries on our planet. Jagged mountains, fjords, hot geysers, ice fields carved into the landscape. Stunning yet intriguingly black sand beaches, such as Reynisfjara Beach. Most of the sand on beaches is generally formed from rocks that have broken down because of weather changes and erosion through thousands or even millions of years. And on Reynisfjara, the sand is a striking black color, and that's because of volcanic activity. Lava came out of an erupting volcano, got to the surface, cooled, and then hardened in the Atlantic Ocean, creating such a fascinating black hue. This beach is so magically stunning, but it's also very dangerous because of its sneakier waves. That's when a few smaller waves join together into a single, really big one. This phenomenon can happen when ocean currents force waves together, or in the case of Reynisfjara, when such waves come from an offshore underground cliff and get an even stronger pulling effect. Considering the ocean's low temperatures too, it's definitely better to just take pictures from a safe spot. Some trees talk to each other, not the way we do, of course, but, for example, acacia trees that grow over the African savanna can warn each other if there's something dangerous coming. When some animals, such as antelopes, gobble up its leaves, the tree immediately starts producing more tannin, which is toxic to animals. They also emit a special type of gas that travels through the air and warns other trees they should protect themselves too. You're stargazing, such a chill night, and then a flash of bright light streaks through the night sky. A shooting star, so cool. But what we see is not actually a star, although we call it that way. They're meteors, which are basically small chunks of dust and rock moving through space. As they're passing through our atmosphere, they cause something called friction when one thing rubs against another, and that's why they glow. Also, the friction causes heat. Dust and rocks get extremely hot as they fly through the atmosphere, and the heat makes them glow until the moment they burn out and turn into what we call the shooting star. Sunsets in deserts are extremely beautiful because of the spectacular colors they produce a bit more than elsewhere. Sunlight consists of various shades of the color spectrum. When the sun is high in the sky, these colors mix together and our eyes see them as white. But as the sun gets lower, its rays have to go through a thicker layer of atmosphere before they get to us. The atmosphere then scatters shorter wavelengths of light, like blue and purple, before we can even see them. That's why the longer orange and red wavelengths stand out. In urban environments, air pollution can make sunset colors duller than everywhere. The clean air in deserts allow the vivid colors coming from the sun to shine through at twilight. Also, the moisture, water vapor, and rain-engorged clouds can mute the sunset's hues. Since there's no rain, clouds are thin and wispy, so they filter and reflect sunlight instead of blocking it. Bamboo grows really fast. It's actually the fastest-growing plant on Earth, sometimes growing about 3 feet in just one day. You can find it in dense forests, where only a little light gets to the ground. which means bamboo is under strong pressure to reach the sunlight as quickly as it can. There's an underground stem that connects bamboo shoots to their parent plant, so the shoot doesn't really need leaves of its own until it gets to its full height. Also, bamboo grows faster than other plants because it doesn't waste its time and energy on growing rings that thicken the stalk. It's just a thin, hollow stick that grows straight up. You'll notice some of the big trees have shallow root systems, sometimes even 10 inches deep in the ground. The roots generally need access to oxygen and water, and they can mostly find it in special underground pockets called soil pores. When a tree has ideal moisture and soil conditions, it can send roots deeper down under the surface and get what it needs. But most of the time, conditions are not perfect, considering bedrock, stones, and compact soil that physically prevents the roots from going down. Such obstacles also prevent the roots from getting the needed oxygen. So, when life gets tough, the tree will take an easier option. Its roots will stay close to the surface and spread out in different directions. Drought conditions are another reason trees can have shallow root systems. By staying closer to the surface, they can take most of the rainfall collection. Plants are exposed to the sunlight most of the time, but they still don't get sunburn. They appeared on land about 700 million years ago, and one of the key things they needed to survive was something that would protect them against the ultraviolet rays coming from the sun. Those in the sea had seawater as protection. UV radiation is mostly responsible for sunburn, so land plants developed a special protein that detects it. This protein sends signals to the cells to protect the plant from the damage and effects of UV radiation. Basically, it's like they produce their own natural sunscreen, but this still doesn't mean they're 100% protected. You know that common belief that if you water plants in the midday sunshine, this can cause their sunburn? Some think droplets of water act as tiny lenses and then focus the sunlight onto the leaf surface. But they're not strong enough to actually focus sunlight from a water droplet onto the surface of a leaf. It's just that their natural sunscreen doesn't mean total protection. Too much exposure to UV radiation damages cells in the leaves and bark of the majority of plants. Earth's core is as hot as the surface of the sun. You'd think it could easily melt our entire planet, especially since the core is only 1,800 miles away from the surface. If the sun were so close, we'd be like French fries. But we're alive because the center of the sun is surrounded by a mantle of rock that's mostly solid. The crust we walk on actually floats on that mantle and protects us. If the sun was close, we'd only have empty space to protect us, and you and I wouldn't be talking. Also, to melt the entire planet, you'd need way more energy than the heat in its core. So there. Massive tsunamis, destructive tornadoes, giant meteorites, devastating earthquakes. Ooh, better have insurance. But all these are minor natural disasters compared with the eruption of a volcano. Some volcanoes can destroy a city, as it was with Pompeii, or some islands in the Pacific Ocean. But there's a dangerous type of eruption that can destroy all life on the planet. This type is called flood basalt. But first of all, let's figure out what a volcano is. Rivers of hot liquid metals and incandescent rocks flow deep inside our planet. And the deeper it gets, the hotter they are. The source of this hot mass is the mantle, which is the middle layer of Earth, located between the core and the crust. These fiery streams are called magma, and it flows everywhere. But we don't feel its heat because of the thick layer of our planet's crust. Magma is lighter than the crust, so it always tries to break out to the surface. And in some places, it succeeds. At the junctions of tectonic plates, it splashes out when one plate moves under a thicker one. When magma reaches the surface, it becomes lava. This substance burns the ground around and cools down quickly. It hardens and forms a new layer of rock. The following splash of magma falls on the top of this layer. Thus, a mountain appears layer by layer over millions of years. And in its mouth, a fault of tectonic plates splashes out magma. This mountain is called a volcano. It spits lava and ash into the sky, then falls asleep and wakes up again during seismic activity. Now imagine that several giant volcanoes begin to splash out an infinite amount of magma. It just doesn't end and covers an entire continent. This is a flood basalt. And one day, it did happen. About 252 million years ago, in the northern part of our planet, a lot of magma accumulated under Earth's crust. Trillions of tons of hot rock were concentrated in one place on a gigantic territory. And gradually, all this fiery energy began to seep out of the ground. Hot gas started to come out in different places in this territory. The ground shook endlessly, and the crust rose hundreds of feet, all pointing to the approach of an imminent catastrophe. And then, at some point, magma began to pour out. Giant fountains of fire burst out of the ground. Do you know these geysers in Iceland? So imagine the same things, but dozens of times higher and with hot lava and ash instead of water and steam. The ash and lava flows were so strong that they reached the clouds. Under Earth's crust, there was a gigantic bubble of magma, and it squeezed out fiery jets under the pressure of rock and ground. The rift was getting bigger. Magma was flowing out everywhere. It began to fill the entire North Continent. The flood of lava spread wider and wider. The streams of molten rock seemed endless. Layers of molten basalt rock overlapped one another, forming a giant tsunami of lava 160 feet high. It poured out of the ground for hundreds of thousands of years, flooding forests, rivers, lakes, and meadows. At the same time, billions of tons of volcanic ash rose into the sky, which could lead to a volcanic winter, since sulfur dioxide in the ash reflected the sun's rays. This might have lowered the temperature on the continent by several degrees. Then, dust and ash probably condensed and formed giant clouds that watered the surface with toxic acid rain. But after that, the cooled lava formed a giant thick shield, preventing magma from seeping out of the endless fire bubble. The global catastrophe was over, but only for a short time. Trillions of tons of magma were still flowing under a thick layer of solid basalt. The fiery rivers couldn't reach the top, so they spread out to the sides. As a result of this expansion, huge nets were formed under the thick rock. They ran in different directions like a spider web and heated Earth's crust. Gases started coming out from under the surface again. More and more energy accumulated there, until an explosion of unimaginable force occurred. In addition to magma, carbon dioxide and ash escaped to the surface. They filled the atmosphere and caused the greenhouse effect. The temperature on the whole planet increased by several degrees. This release provoked another catastrophe that began in the ocean. There were deposits of methane, an explosive gas, on the seabed. Under ice-cold water, the methane was frozen and harmless. But the greenhouse effect in the atmosphere warmed up the entire ocean. Millions of tons of methane began to rise to the surface. This gas is more potent than carbon dioxide. Therefore, when it hit the atmosphere, the temperatures on Earth increased again. The whole globe turned into a hot sauna. In previous cool and humid places, the temperature reached those of a modern Sahara. Of course, most animals and insects couldn't survive such a cataclysm, but ocean life took much more damage. The heat and methane reduced the amount of oxygen in the ocean. Fish and other marine life couldn't survive in such conditions. New problems appeared when anaerobic bacteria started to multiply in non-oxygen water. They fed on methane and carbon dioxide and released hydrogen sulfide, a toxic substance that poisoned water even more. About 75% of land animals and 95% of the ocean's inhabitants went extinct. This flood basalt eruption was the only disaster in the planet's history that destroyed almost all plants and significantly reduced the insect population. Several species of the hardiest animals managed to survive in these conditions. The planet took about 10 million years to recover completely. After that, evolution began a new process of developing life. And here are two pieces of news. The bad one is that flood basalt will happen again and will be no less devastating than 252 million years ago. The good news is that it will happen in hundreds of millions of years. But when that happens, humanity will need to be prepared. It will start on the ocean floor. First, lava fountains miles high will begin boiling the water and emit sulfur dioxide into the atmosphere, where it will reflect sunlight. Along with ash and magma, a massive amount of water vapor will rise into the air. Livestock won't survive, and people will have breathing problems. Acid rain and increased humidity caused by the evaporation of the oceans will lead to the corrosion of buildings. All flights will be canceled. People will have to wear gas masks. Many animals won't be able to handle this eruption, but humans will adapt quickly. But then another and another eruption will follow, and this endless catastrophe will soon deplete the resources of humanity. Plants and trees won't recover so fast, and oxygen production will be significantly reduced. Let's hope that humanity will have colonized other planets, including those outside the solar system by that time. And now, let's jump back to the present. About 70% of the seismic activity associated with volcanoes occurs underwater. So let's see how ordinary volcanoes on the ocean floor work. Water, as well as land, rests on tectonic plates. Therefore, if their structure is broken at the joints, magma seeps through them. But unlike terrestrial volcanoes, lava here doesn't spread in different directions, burning everything it meets. It solidifies under the pressure of cold water. Underwater volcanoes can erupt for a long time with breaks in between. Magma covers the seabed. After another 100 or 1,000 years, a new eruption begins and a new layer of rock forms over the previous one. Over millions of years, layer by layer, magma is rising. And then, one day, a volcano rises out of the water. Magma splashes out of it and increases its height. And now we have a large volcanic island. Then the volcano falls asleep and life appears on the newly formed piece of land. Magma flows from the planet's mantle, filled with various chemical elements. This hot mix saturates the soil with useful substances and thus promotes the growth of plants and trees. Then birds and other animals arrive there, and the volcanic island turns into a paradise. Then humans arrive and pave over paradise to put up a parking lot and a franchise burger joint. A purple sunset. You must have seen one of those at least once in your life. Normally, it's nothing ominous and has to do with the way light travels. The light that the sun produces is white. When it goes through a prism, you see light waves of different colors, from red and orange to blue, green, and indigo. Light normally travels in a straight line if there's no obstacle in its way. The shorter light waves, including blues and purples, are scattered easier when they meet with those obstacles, like molecules and aerosols in the atmosphere. Because the sun is low on the horizon at sunset and sunrise, its light has to pass through more molecules that scatter the violet and blue light. The colors that your eyes pick up, then, are yellow, orange, and red. But, with the right conditions, you can see the gorgeous purple sky. Sometimes purple sky appears for much scarier reasons. It can be caused by hurricanes, wildfires, or dust storms. The concentration of vapor in the air increases, and the light scatters more than usual. Dust, a setting sun, and low cloud cover all contribute to this natural show, too. The sky turns orange and red at dusk if there's still enough light. Then it gives off pink hues, which mix up with a dark blue sky above. Now, do you remember what happens when you mix pink and blue? You get the color purple. Not every hurricane makes the sky turn purple, and trying to predict if it's going to happen is like trying to forecast a rainbow. Still, people reported several major hurricanes made the skies turn purple. Now, green skies might look just as spectacular as purple ones, but they actually also scream danger. They're usually there to tell you a thunderstorm, hailstorm, or a tornado is somewhere nearby. The unique color is a result of yellow sun rays getting mixed with the blue light coming from storm clouds. So you're enjoying a nice day by the ocean with a fresh breeze in your hair, when suddenly you notice the water starts retreating from the beach at a huge speed. This is a sign for you to start running as fast and far away from the beach as you can. This most likely means that a tsunami is on the way. A quick reaction maximizes your chances of survival. Now, if you notice the sea level is rising, but it doesn't seem too extreme, it could be another sign of an approaching tsunami. It happens in 40% of cases, and the incoming water is the first tsunami wave. The next one, way larger and more dangerous, usually follows in about 10 minutes. Another thing about tsunamis is that they like to arrive with some loud sounds. People describe them as thunder, the sound of a locomotive, a helicopter, or just a loud boom. Do you see a channel of choppy water on the beach? It's in your best interest to stay away from the water. There might be a rip current under the surface that can be extremely dangerous. Sometimes waves hit the shore in a weird way, which forms these rip currents. You might see a strange break in the waves, or an area with a different color than the rest of the water. Random bits of seaweed going in all directions is another rip current warning sign. If you happen to find yourself caught in a rip current, try to stay afloat, but don't try to go against the current. You'll only waste precious energy. Scream for help and try to float your way along the beach. Once you break out of the current, swim diagonally to the shore. The next time you spot conically shaped clouds in the sky, remember it's a good time to start looking for some shelter. If it just stays like that, a severe storm is on the way. But if a cloud of that shape starts spinning around, it means it's about to transform into a tornado. If you have bees nearby, they can save you from big trouble one day. These hard-working little guys get more active than usual when they feel like a storm is on the way. They speed up to collect more nectar before it hits them, and once they're done with it, they'll always come back to the hive 10 to 15 minutes before heavy rain, even when there are no obvious signs of it coming. Their secret is super sensitive hairs on the back that can pick up electrostatic buildups from storm clouds. For centuries, people have noticed that animals act weirdly a couple of days before big seismic events. Dogs can't stop barking, cows halt their milk, and toads, rats, and snakes leave their homes. It looks like animals can feel smaller initial shock waves that humans don't even notice. Scientists have tried to find some legit explanation for it and run endless tests and experiments. But so far, they're still on their way to explaining this mystery. Can you smell ozone in the air? When a thunderstorm is on the way, it's the most distinct and pungent smell you can pick up. An electrical charge of lightning sets it free from higher altitudes. The other, more pleasant smell of rain is petrichor. Rainwater wakes up molecules on plants, trees, concrete, and asphalt. Their aroma spreads all over the place. You can even feel that smell in your own mouth. All those positive ions in the air that a lightning bolt sets free gets mixed with ozone and your saliva, and that's how you get that bitter metallic taste. When lightning is about to strike, you might hear bizarre crackling, buzzing, or vibrating sounds coming from metal objects nearby. Your palms may begin to sweat, and then you can feel your hair stand on end. That's a clear call for action, and that action is to run for your life. Positive charges are going through your body trying to reach toward the negatively charged part of the storm. Trust me, you don't want these charges to meet. If you see no shelter that you can reach fast, try to make yourself smaller than the objects around you. Drop down your umbrella and stay away from wire fences, metal pipes, rails, and other metallic objects. And don't lie flat on the ground, it's likely wet, which means it's a great conductor of electricity. If you suddenly notice crevices in the asphalt next to your house, it could be a sinkhole warning sign. Inspect your house on the inside. Does that door begin to jam? Or maybe there's a gap where the walls meet the ceiling. Uneven kitchen cabinets and drawers, slanted floors, stairs that begin to slope, water leaking after every rain, and displaced moldings are all signs that a sinkhole is about to open. To find out if it's definitely a sinkhole and how dangerous it is, you gotta consult with an engineering company. If you find a sinkhole that's already there, you gotta stay away from the sinkhole area. Fence or rope it off to make it less dangerous for others. You'll need professional help to fix it. Some volcanoes scream when they're about to erupt. Small earthquakes, which often happen before, produce a hum. It's mostly non-audible to human ears, but sometimes it reaches a frequency that lets you hear it as a strange rumbling or hissing sound coming from the ground. This noise is known as a harmonic tremor. With some volcanoes, it's the sound of magma bubbles vibrating when they're going through crevices in the crust of the earth. But it's not always like this. If scientists manage to understand what exactly causes these volcanic screams, they could create a limited early warning system for volcanic eruptions. If you're out in the wild, pay attention to the water in creeks, streams, and rivers. If its level is quickly falling, even if it's raining, this might be a sign of a nearing landslide. And if you hear a faint rumbling noise or unusual sounds, like boulders knocking together, it could mean debris is on its way to you. It's a sign to head to safety immediately, like right now.